Hi, Professor. This is group number 4, and we are here for our presentation on analyzing road collision severity in South Australia. So, this is a project and it examines road collision data from 2019 to 2023, uncovering key trends in accidents, casualty demographics, and vehicle involvement. So, we are using real world data to try and build data analytical skills and generate meaningful insights so that we can promote better road safety. This is our team with Ashwin Sudhakar as project manager, Rinsia Ibrahim as data analyst. I'm Shivani Selo, the data engineer, and Varghese George as the data scientist. Now, the next part of dataset cleaning will be presented by Ashwin.
I'll be explaining about the dataset cleaning of our project. And before starting, it is to be noted that we have three datasets, that being a crash dataset, unit, and casualty. And since it all follows the same way of cleaning, I'll be focusing on how we clean the crash dataset for the explanation part. So let's jump to the codes. So here we just load the dataset from the path and just display the basic information, and then we counted the missing values in each column to make sure that how many of those we have in our dataset, which turned out to be quite a lot for DUI and drugs involved. So what happened was the DUI and drugs involved in our datasets had this issue that they were only given a yes if it was involved, and they were left null or empty if it's not related to a DUI or drugs involved. So we had two options to either drop the entire thing or to fill it with a no. So that's what we did by handling the missing value here. We just replaced the unknown to a no, so that we can use the DUI and drugs involved later on in our project. And then we try to see that if we have any more of those missing values, which was zero, so that means the code over here worked fine. And then we converted the data set, that's the numerical and the categorical values, to be into a standardized manner. So let's, for an instance here, month is given with the M being capital, M being small letter, and ended in a capital letter. So that's not standardized. So what we did was to convert those every categorical value into a small letter. So we use the str lower to convert it to the small letter, so that it's standardized throughout the dataset, which was essential. And then we checked if we still have any duplicates, which were none. That means it's zero over here, and we cleaned the dataset and then saved it to a new file path. Later on, what we had to do was we combined the cleaned data sets. So as I mentioned, we have three, so we need to work in an easy manner. We had to combine all those three into one. So what we did was to take the report ID, which was unique in all, which was constant in all three data sets, and match those data sets with the other two data sets. So I'll show the code over here just in a second. So over here, what we did was we load it as usual, and then we analyzed our dataset shape. So as you can see, the huge difference between the crash dataset and the units, with 63 and 99,000 difference. And so we identify the total matching report ID, which came down to 16,000 in all three. So we kept that 16,000 throughout all the data sets, all three data sets. So that's what happened in keeping only matching report ID code and ensuring all data sets have the exact number of rows. So not just that the report ID need to be matched, but we ensure that all the three data sets had the exact same number of rows, so that it would be easier in that way too. So, and we checked if it justified the code, so it did. So all the three data sets contains the same number of rows and columns, or I mean rows, and we save the final clean data set into this path. That's all about the cleaning part, and the next one will be a designing feature selection. Thank you.
Hi, I'm Shivani. And now that our data sets are cleaned, the next step is feature selection. That is essentially identifying the most important variables for predicting collision severity. So, our approach included extracting key attributes from the crash, unit, and casualty data sets, then using correlation analysis to identify high impact factors, and also eventually removing redundant or low impact variables to enhance models efficiency. So Going back to our Python code. So here you can see that we have loaded our data sets, all three data sets into the terminal, and then we have filtered out the relevant columns and retained only the features that we really want for each data set. And then we have eventually saved these feature selected data sets into new CSV files. Then we have just displayed the basic summary for each uh, data set here. Now we go back to our presentation. So this is the code that we just went through. So coming to feature selections for each data set. So in casualty data sets, we have retained attributes such as casualty type, age, sex, injury severity, seat belt and helmet usage, which are very critical for analyzing the accident outcomes. Then for crash data sets, we have focused on weather conditions, time of day, crash type, DUI or drug involvement, as these are significantly uh, impacting the accident and risk severity. And for units dataset, we have only retained vehicle type, vehicle year, driver's age and sex, unit movement, and number of occupants, because the other ones were not of much use. The next part is the EDA and visualization, which will be presented by Rinzia.
Hi, I'm Lindsay Ibrahim. Let's explore the exploratory data analysis and visualization section of our MRP. So using the data prep library, we visualized each feature of our three data sets to examine its distribution patterns and correlations for deeper insights. So let's have a look on to that in our Jupyter notebook. So here we have imported the necessary library files to perform exploratory data analysis, and we have plotted the casualty data set here where each feature of the data set is visualized. Next, we have a bar chart showing the distribution of injury. So most victims received hospital treatment followed by private care or admission. Fatalities were the least common, indicating that while many require medical attention, most injuries are not life-threatening. Next, we have plotted the crash data set with each feature visualized. And next, we have plotted the weather condition in crashes. So here we can see that the road crash distribution by weather, most accidents occurred in dry condition with the fewer during rain. And as with other data sets, we have plotted the units data set also to visualize each feature. And this histogram, it shows the distribution of vehicle manufacturing years in crashes. Older vehicles are less involved, while crashes with the newer cars are more frequent. The peak around 2010-2020 suggests that most accidents involve newer vehicles, likely due to their higher numbers on the road. Next is the accidents by vehicle type. So the graph highlights the top 10 accidents by vehicle type, with the sedan leading, followed by station wagons. So my teammate Verghese will be explaining the next section. Thank you.
Hi, I'm Varghese George, and I'm here to present the development phase, the predictive modeling. Let's move into the first slide. Here, we first imported all the required libraries, and there are essential for data manipulation, visualization, and modeling. We loaded the three data sets, and we used to preview it using the head. Like we can see, like this, the loading libraries, loading data sets, and the next we extract the year and one from the report ID. Um, these steps, we prepare the crash data is based on the analysis. We check the available column, then extract the year and month and values from the report ID column using the regular expressions. The code and the output over here. And the next is the visualization for the predictive modeling of the data sets. First is based on the monthly trends of the crash over time. Here we created the time series plot to visualize the monthly crash trends. After dropping the missing dates, we counted the crash by months, converted the index to time series format, and they plotted the trend using matplotlib. As shown as the output, there is a noticeable spike in lately 2090, followed by a significant drop and flat trends over the afterwards, like you can see here. And the next is time series analysis. For the future analysis pattern over time, we perform the seasonal decomposition of the monthly crash data using seed decomposition method from the SAT models. We split the series into components, trends, seasonality, and residuals. It helps understand the underlying pattern and irregularities in the crash frequency. And the output was here, like this slide shows the visual output of the decomposition. The first graph is the original crash trend. Below it, we have the trend component showing the rise and fall. Then the seasonality, where reveals all the repeating patterns, and lately residual, the highlight notice, and the randomness of the data together. These provide a comprehensive view of the crash timelines. And the next is merging data for the predictive modeling. In these steps, we merged all three data sets, crash casualty unit on the report ID field to create the unlimited data set. Then we use one hot encoding to convert the category variable for modeling. After that, we use the correlation analysis to identify important features. And the output was is on the heat map. Like the heat map uses the feature correlation. Strong positive and negative relationship can be seen using the color. For example, variables like crash type, weather, and vehicle type shown some significant concerns. This helps to decide whether the feature to keep for the modeling. And for the model accuracy, finally, we trained the random forest classifier to predict crash outcomes. We split the data into training and test sets, trained the model and evaluate it. As shown, we achieved an accuracy of around 97.6%. This classification represents on the high precision record and F1 score, confirming that the model performed well in identifying crash types. Yeah, that's for my topic, and I will show the code that we done. This is the code for the predictive modeling with crash data. So first we use the important libraries like cloud data and check the columns extraction. We merge the column like month and year with the report ID. Yeah, all of these are here. There is the monthly trend crash over time analysis, and the next analysis over here. Yeah, the heat map, all are performed well. And thank
Hi, I'm Shivani. So, moving to our research questions, we analyzed various factors influencing road collisions, including weather conditions, vehicle types, gender involvement, and traffic control measures. So, key factors influencing the severity of traffic collisions. One key finding is that dry weather conditions result in more accidents rather than rainy conditions, mainly due to higher traffic volume and increased speeding in favorable conditions. Then, as you can see, sedans are the most frequently involved vehicle type in accidents, primarily due to their high presence on roads and their involvement in urban traffic conditions. If we look at the gender wise split, males are involved in more collisions than females, which is likely due to higher driving exposure, occupational influences, and driving behavior patterns. Looking at this collision counts by area speed chart, we found that collisions occur most frequently in areas with a 60 km per hour speed limit. These are typically urban areas with high traffic density and complex road structures. Um, then, looking at this DUI versus non DUI collision breakdown, interestingly, despite concerns over DUI, data shows that most accidents are non DUI related. This suggests that stricter DUI laws and alternative transport options like ride sharing have a positive impact. Now, coming on to the second research question, how does seatbelt helmet usage impact injury severity in traffic collisions? So here you can see that seatbelt and helmet usage plays a crucial role in injury severity. Wearing a seatbelt significantly reduces fatal and severe injuries, while helmets protect against head trauma but not eliminate all risks.
Hi, it's me Rinsi again. Now let's look on to the collisions by time of day. From the graph, it is clear that most collisions happen in daylight due to higher traffic, but night crashes are more severe due to poor visibility. Low light and bad weather increase accident risk, emphasizing the need for better nighttime road safety measures. Traffic control measures on collision frequency. This slide shows that location without traffic control see the most crashes. Traffic signals, stop signs, and roundabouts significantly reduce collisions, with roundabouts being the safest. Now, the collision trends from 2019 to 2023. During the COVID-19 pandemic, fewer cars on the road led to a drop in accidents. In recent years, improved road safety measures in South Australia have further reduced collision numbers, highlighting the impact of regulation and traffic control. Now, let's have a look onto the project cost. The graph displays the current project cost for each phase, with the initiation phase being the highest, followed by design phase. The development phase, which is still ongoing, has incurred $1,105 so far. So to conclude, our findings show that men are involved in more accidents than women. DUI-related collisions remain low, and seatbelts and helmets significantly reduce injury risk. Most accidents happen in dry weather, and nighttime crashes tend to be more severe. Urban areas with a speed limit of 60 km per hour see the highest number of accidents. However, proper traffic control measures play a crucial role in improving road safety. Sedans are the most involved in accidents because they are so common. The number of collisions varied from 2019 to 2023, influenced by things like COVID-19, the economy, and road safety effort. It is important to consider factors like seatbelt use and traffic controls when working on road safety strategies. So here are the links for our presentation on Google Drive and YouTube. Thank you.